This is an example of a system of equations that we did in section 7.1. And in this example, one of the equations is nonlinear. It's actually a parabola. The other equation, equation B, is just a straight line. To solve this problem, we're going to solve for y in equation B because it's the easiest to solve for. So we get that y is equal to 2x plus 1. Y is an expression. We're going to call it equation C. Second, we're going to substitute this expression into equation A and simplify. As we can see, it'll be a quadratic equation, and here you have a choice of solving that quadratic equation with by trying to factor it and using the zero product property, or using the quadratic formula. Factoring it and using zero product property would be the easiest. So I'm going to get the quadratic equation that I have here in ready form. That is, I'll combine like terms and I'll move all the terms over to one of the sides. And then if I try to factor it, I see that it does factor nicely, and I can get the answers using the zero product property. So x equal 2 and x equal negative 4. Now, I am not done at this point. These are only x values. I'm looking for coordinate points, x comma y and x comma y. So the next step, step number 3, is to get those coordinate values by substituting the x's one at a time into one of the equations that I have. The easiest equation would be equation C. So by substituting first the first x value, 2, into that equation, equation C, I get that y is equal to 5. So one of the solutions to the main problem is going to be 2 comma 5. I repeat the process with the other x that I got of the x equal negative 4. I plug it into equation C and I simplify, and I get the answer for y to be negative 7. So my other answer is x equal negative 4 comma and y equals negative 7. So in this case, we see that we got two solutions. But sometimes there are no solutions. And this happens when the quadratic formula yields imaginary solutions. Example, let's take a look at this equation. Let's say that instead of getting the quadratic equation that I got previously, that is x squared plus 2x minus 8 is equal to 0, which we were able to factor nicely, let's say that instead of that equation, we had gotten this other equation, x squared minus x plus 3 equals 0. And if we solve that, we would see that factoring it would not be possible. So at this point, I would use the quadratic formula. Maybe it would factor, but it's not going to yield nice answers. So then I recommend then using the quadratic formula at this point. So I'm going to get my values for the coefficients a, b, and c and plug them into the quadratic formula. And at that point, I would simplify. And if you look closely, though, at the square root portion of it and solve that, you would see that you would get the square root of negative 11, which is an imaginary solution. Hence, there are no solutions to there would be no solutions to this problem. And that is indicating that the parabola and the line do not intersect at any point, whereas the original problem would be indicative of a parabola and a line intersecting at 2 points. And that is it.